Hello everyone. Hello Professor. My project topic for the capstone is default of credit card clients. Coming to the problem statement, my project is mostly helpful for the financial institutions like banks, which provide the financing, or they have a very important role in delivering essential financial services to the public. The challenges lies in financial institutions, particularly the banks, are maintaining the integrity and minimizing the risks by giving the credit score or improving the credit methods. So there is an very serious need for precision in assessing the creditworthiness to enhance the risk management and ensure the financial stability of the society. The main motive of the project is that the model employs diverse factors to predict customer behavior, distinguishing between the potential defaulters and non-defaulters for the upcoming days or the upcoming months. The primary objective is to assess the client's ability to fulfill the credit obligations in the coming months, or identifying the prospective customers capable of their credit balances. So this model aims to evaluate the timely payment capability of customers, defining default as a failure to meet interest or the principal obligations on the loans and the credit card payments. I have received the data set from the ICS. So the data sheet is about the a credit card company which has the information of nearly 30,000 clients in the city of Taiwan. Uh, this data set includes the data on 25 variables, including the demographic information or the credit information, payment history, or the bill statements or of the credit card users from the month of April 2005 to September 2005, as well as the information of much more information like their marital status or the education levels, uh, and so on. And coming to the description, so in my data set, the independent variables are like the customer ID, credit limit, gender, or the amount of the previous payment, uh, which is like what amount the customer has made in the previous month, or the bill statement, or the history of the past months made in the past some of the months, or the level of education, the age, and gender. And my dependent variable is default column, which is like a customer uh, has made the payment or not. So coming to this, 0 means a no and 1 is yes. So a default is like a customer is considered as default when he cannot make a payment in the coming months, or he did not make the payment. So in understanding the data, uh, I have I have replaced some of the column names, which most of them were like x1, x2, and so on, with the corresponding meaningful names to the each column, and check the data type of the variables and observe that all were in the object type. Consequently, change the data type of the variables to int format. I have also detected some undocumented values in certain categories such as education or marriage and payments, and I have merged these categories into a single combined category due to the absence of the recorded values. This is one of the heat map, which shows the correlation of variables using the heat map. It shows the relation between each of the columns given. Uh, in this uh, in this data analysis, we can observe that on the bar on the left side shows that most of the number of clients were from grad school and the university, where university level education clients have made more payments, and they have not missed the payments and made it in time. and like in university level education uh, clients who are not default, which means they did not make the payments, are like nearly 33,000 people, and high school and the others are very less in with as compared to the uh, grad school and university level educations. And coming to the bar on the right side, we can see that male and female percentages are almost equal as 76 and 79%. And but uh, coming to the default, who have not made the payments, uh, out of mostly all the we can see that 76 and 79, whereas 21% is the only ratio in the whole 100% of the female clients where they did not make the payments on time, whereas more males have not made the payments on time. So the bar on the top shows that the credit limit for the like the more credit limit, the people with more credit limit are very less, whereas people with less credit limit are more. Uh, like from 0 to 2 lakh are the credit limit with more people, and whereas after the 4 lakh, there's very less people with that credit limit. And coming to the bar on uh, the graph on the bottom, it shows that the age group between 25 to 40 are more non-defaults, which means that they have made payments on time. So the graph on the left side shows that the average balance over time, which means that this is the amount where the credit card the clients need to be made in these months by observing the such months. And the one on the right shows that how clients have made payments. For example, in the after the month of June, uh, clients have made more payments in more amounts, whereas in the month of May and June, they have made significantly less payments. For handling the imbalance in the dataset, I have used oversampling technique and synthetic minority oversampling technique. I have tried to implement some of the machine learning classification models to s- for this project, like logistic regression neural networks, mixed naive Bayes, and support vector machines. I chose the logistic regression as my baseline model, and after analyzing the multiple combinations and parameters, uh, with learning rate, tolerance, and max iterations, I've got the best result with accuracy of 53% and precision of 68% and recall of 77%. And coming to the mixed naive Bayes model performance, I've choose the Bayes mixed naive Bayes model because it takes both categorical and continuous features to fit the data of the categorical features into this model. I have performed data processing using label encoder, and for this model, I have got an accuracy of 66% and precision of 79% and a recall of 66%. And for the neural networks model, I have received the training accuracy of 72% and a recall of 64% and testing accuracy of 69%. After comparing the results and considering the time taken for each model to perform, it is determined that the mixed neighbors performed better than the other models. As we consider recall as our performance metric, we observe that it has obtained a value of 0.77, which is better than the other models, and it took a very less time. And for the neural networks, we can and support vector machines, we can also further tune with hyperparameters for better accuracy and recall values. So I would like to propose mixed neighbors uh, as our best model. Thank you all for your time.